Dear students, welcome to our maths class. In previous class, we discussed about differentiation. So we learned that how the differentiation comes, what is the basic for the differentiation, and we proved some formulas, or we say standard forms. So now in this class, we will discuss some more problems of the differentiation. So there are so many functions, and for different functions, we follow different methods and apply the standard forms. Let us see. So here mainly we discuss about trigonometric functions, how to derive the trigonometric functions. Objectives of the class. On completion of this period, you would be able to derivatives of trigonometric functions. There are so many types of functions: algebraic functions, exponential functions, trigonometric functions, inverse trigonometric functions, hyperbolic functions, like this. So we have so many functions. Here we discuss about trigonometric functions, and we know how to derivative or how to differentiate the trigonometric functions. Derivatives of trigonometric functions. Today's subtopic name is derivatives of trigonometric functions. Recap. In previous class or in previous classes, we learned limits and basic concept of differentiation, or we say first principle of differentiation. So in the limits we have so many standard forms. Number one is limit x tends to a, x power n minus a power n by x minus a equals to n into a power n minus 1. Second formula or second point, limit theta tends to 0, sine theta by theta equals to 1. Number third, limit theta tends to 0, tan theta by theta equals to 1. Can you give examples of trigonometric functions? See here, you can say number one, y equal to sine x. Y is a function in x, that is in trigonometric functions sine x. And second one, y equal to sec x. And third one, y equal to sec x plus sine x. Differentiation of sine x from first principle. First principle, we can say this is the basic concept of differentiation, and after finding the value by using first principle, we can say that it is a formula. We can consider it as a formula or derivative of that function. We can write, see, let f of x equals to sine x. Here sine x should be top right side, but by mistake it came under the f of x. Let delta x be increment in x, then f of x plus delta x equals to sine of x plus delta x. We know f of x equals to sine x. So in place of x, we are writing x plus delta x. So in the right side also, we have to write x plus delta x in place of x. That is sine of x plus delta x. By definition, f dash of x, or we say differentiation of f of x, or differentiation of sine x. So simply say f dash of x equals to, first principle is here we are taking, that is limit delta x tends to 0, f of x plus delta x minus f of x by delta x. F dash of x equals to limit delta x tends to 0, sine of x plus delta x minus sine x by delta x. So here we are substituted the functions, that is f of x plus delta x and f of x. Now we do the simplification. F dash of x means d by dx of sine x equals to limit delta x tends to 0. So in the numerator we can see it is in the form of sine c plus sine d. So sine c plus sine d we can write 2 sine c plus d by 2. Sorry, the numerator we can observe it is sine c minus sine d, because it is f of x plus delta x minus f of x. So minus, in the numerator between two sine terms we have minus, so it is in the form of sine c minus sine d. From transformations we can express sine c minus sine d as a product, that is 2 cos c plus d by 2 into sine c minus d by 2. So we can write 2 cos of c means x plus delta x plus d means x, so c plus d by 2 whole divided by 2 into sine c minus d, that is x plus delta x minus x minus x get cancelled, delta x by 2, and here x plus x we can write 2x, so 2x by 2 means x, so that's why here taken in cos of x plus delta x by 2 into sine delta x by 2 whole divided by delta x. So here the divided is we can write under sine also, no problem, because in the numerator we have one term in product form. Then next step, delta x tends to 0 means delta x by 2 tends to 0. So here 2 we can write under delta x, which is under sine delta x by 2, and cos of x plus delta x by 2, so we can give the limits for cos and sine. So limit delta x by 2 tends to 0, cos of x plus delta x by 2, and limit delta x by 2 tends to 0, sine of delta x by 2 by delta x by 2. So we already know as delta x tends to 0, then delta x by 2 also tends to 0. Just divide both sides with 2. Therefore, we have now finally d by dx of sine x equals to cos x, because here first term in the product of the cos and sine, if we substituted cos x we have, and in the next the sine, it is in the standard form, so that is 1. So 1 into cos x, or cos x into 1 equals to cos x. So this is we can take as a formula. So it is given in a background color shaded, that is green color background shaded, and kept in a rectangular box. So we can say sin x derivative equals to cos x, or derivative of sin x equals to cos x, d by dx of sin x equals to cos x, differential coefficient of sin x equals to cos x. Similarly, we can find the derivatives of other trigonometric functions as d by dx of cos x equals to minus sin x, d by dx of tan x equals to sec square x, d by dx of cot x equals to minus cosec square x, d by dx of sec x equals to sec x tan x. So these are all we can find from first principle, as we found sin x derivative is cos x, like this we can find. So after finding, they are given here as a standard forms or formulas. These are helpful to find derivative problems. And dy dx of cosec x equals to minus cosec x into cot x. If we observe, cos x, cot x and cosec x derivatives are in negative. So here the c is common in cos x and cot x and cosec x. So we can easily remember, when c comes in the derivative, the negative will takes place. So it is a technique to remember plus and minus signs in derivative. Solved problems. Differentiate sin x plus sec x with respect to x. So function is given and it is in x, that is trigonometric functions. So with respect to x, so in the question it is asked with respect to x, because function is already in x. function is in y, and if we ask with respect to x, then we have to do after sin x, and we have to differentiate with x also. So that is we see in future classes, or after this type we can see if the function is in another terms and asking with respect to in another term. So then we will discuss how to do. At present, function is in x, and we have to differentiate it with respect to x. So solution: dy dx of sin x plus sec x. So here the function is in summation of two terms. So using property we can separate the d by dx for both, that is sin x and sec x. So we can apply differentiation for each term. So we can write dy dx of sin x plus dy dx of sec x. Sin x derivative is cos x. Dy dx of sec x equals to sec x into tan x. Second question: find dy dx of 2x cos x minus x square into sin x. So here function is having two terms, and in each term having again products. So first take the function and write the derivative symbol, that is our differentiation symbol, that is dy dx of 2x cos x minus x square into sin x. So we can separate, or we can differentiate for each term. So here it is not 2x, it is a 2 into cos x, so it is a multiplication symbol. So take 2 into 2 as a common because it is a constant, and write dy dx of cos x, and minus x square. See, it is written it is not properly typed because x square is not a constant to bring outside. So here we have to consider it is not a x square, it is a like a 2 square. So here you observe, you have to rectify, or you have to change. So it is not x square. Before sin x we have x square, but it is not x square, it is a 2 square. Imagine any number or constant, then only we can put outside. Here 2 in before the cos x we have 2, it is not x, it is a imagine it is a any constant or multiplication symbol. So That's why I have taken common 2 into and divide x of cos x minus, it is not x square, here wrongly typed, it is a constant term, that is 2 square or 3 square or 4 square, so it is also constant, so it written outside, and divide x of sin x. So cos x derivative is minus sin x, so minus 2 into sin x, and here minus x is not, x square is not that, that is any constant square, or you imagine it is a n, it is better. So 2, the question is dy dx of 2n cos x minus n square sin x. So n is here a constant like 2, so 2n outside kept outside, and dy dx of cos x and minus n square, so it is a n not x square, it is n square, so kept outside, and dy dx of sin x, then it is minus 2n sin x minus x square cos x, because sin x derivative is cos x. We already proved here before these problems by first principle. Next question, differentiate sin x by cos x. Here it is in the form of u by v. So solution, we know that d by dx of u by v equals to v du by dx minus u dv by dx by v square. So this is the formula, so it is given in a yellow colored background, shaded and kept in a rectangular box. So d by dx of sin x by cos x equals to, here u equal to sin x and v equal to cos x. So substitute in the formula. Then we have cos x into d by dx of sin x minus sin x into d by dx of cos x whole divided by cos x whole square. We can write it as a cos square x. Cos x whole square equals to cos square x. Now that equals to cos x into d by dx of sin x is cos x, so it is kept in a bracket, minus sin x into cos x derivative minus sin x, so that it is kept in a bracket, whole divided by cos square x. Now cos x into cos x, cos square x, minus into minus plus sin x into sin x, sin square x. So cos square x plus sin square x means 1. It is a trigonometric formula we learnt in first sem, and of course in 10th class or SSC we already know the formula, by cos square x. Next question, find dy dx of 1 plus sin x by 1 minus sin x, that is u by v. We know that d by dx of u by v equals to v into du by dx minus u into dv by dx by v square. So the formula is given in a yellow colored background shaded in rectangular box. So we have to remember this formula, and according to formula we have to substitute. So that equals to 1 minus sin x into d by dx of 1 plus sin x minus 1 plus sin x into d by dx of 1 minus sin x all divided by 1 minus sin x whole square. That equals to 1 minus sin x into, here we have two terms, so differentiation goes to each term. So d by dx of 1 is a constant, so 0, plus d by dx of sin x is cos x, so 0 plus cos x, cos x. So here written cos x directly minus 1 plus sin x into, here also differentiate goes to two terms, that is 1 and sin x. So 1 is a constant and constant derivative is 0 minus sin x derivative is cos x. So 0 minus cos x minus cos x. So here we have minus cos x. So it is kept in a bracket by 1 minus sin x whole square. So here there is no differentiation. So this step also enough for finding differentiation, or you can simplify and then you can stop. So if you want to simplify, multiply the products, that is 1 minus sin x into cos x means cos x minus sin x into cos x, and here minus into minus plus 1 into cos x and plus sin x into cos x. So sin x cos x minus sin x cos x get cancelled, cos x plus cos x 2 cos x. So in the numerator we have 2 cos x by 1 minus sin x whole square. In this session you have learnt, number 1, d by dx of sin x equals to cos x, or we can say simply sin x derivative is cos x. Second one, d by dx of cos x equals to minus sin x. D by dx of tan x equals to sec square x. D by dx of sec x equals to sec x into tan x. D by dx of sec x equals to sec x into tan x. D by dx of cosec x equals to minus cosec x into cot x. And d by dx we can add, because here 4 and 5 repeated, by mistakenly it is repeated, so in place of 5 we can write d by dx of cot x equals to minus cosec square x. So summary, in this session you have learnt the derivatives of trigonometric functions. Finding derivatives of trigonometric functions. So let us see the quiz. First one, d by dx of tan x equals to, four options are given. You have to write or select or choose one option which is correct and write in the bracket. So options are A, sec square x, B, sec x tan x, C, sin x, D, tan x. So from these four, if we know the formula, we say sec square x is the correct answer, that is option A. So here we can see in the correct answer in blue color ink, it kept in a bracket. Now second question, dy dx of sec x equals to, again four options given. We have to select one that is correct one. Options are A, tan x, B, sec x, C, sec x tan x, D, cos x. So sec x derivative is sec x tan x. So the option is correct answer is C. So we can see here in a bracket blue colored letter C. So these are very important formulas. We have to memorize these formulas or standard forms. These forms everywhere we can apply, we use. So we have to memorize, not only in maths, not only solving the mathematical problems or exercise problems. It is helpful or it is used in so many engineering subjects. So you must remember and memorize the formulas. Next question, third one, d by dx of cot x equal to, again four options are given. A, cosec square x, B, minus cosec square x, C, tan x, D, cot x. So cot x derivative means, I already told you one technique. Whenever this starts with the letter C, its differentiation is have negative symbol. So cot x derivative is minus cosec square x. So the correct option or answer is B. So you can see a blue color letter kept in a bracket. Next question, number 4. So it is looking questions, but actually these are standard forms or formulas, and you have to remember these are all comes and find from the first principle. Already one we had, no, we already did and we found. that is for sin x. Like same way we can find all these. So every time it is difficult to find and know the, so we have to memorize these formulas, because by applying these formulas we have to find some more functions with including so many trigonometric functions, product or plus or minus or division. So you have to memorize these formulas. Dy dx of cosec x equals to four options given: a cosec x, b minus cosec x into cot x, c sin x, d cos x. So here also c is the first letter in cosec x. So c means its derivative contains negative symbol. So cosec x here in options only one is negative, so we can directly say b. So cosec x derivative is minus cosec x into cot x. In the third question also, if you observe the options, only b contains only negative. So by using symbol we can select blindly, because remaining are not negative. So for fourth one, answer is b. So dy dx of cosec x equals to minus cosec x into cot x. Fifth one, dy dx of cos x equals to, cos x derivative is, see here again same technique we can follow. C is the first letter of the cos x, so its derivative is contains a negative symbol. So here the four options, only one is negative, remaining are not negative. So we can blindly say the answer is A. So cos x derivative is minus sin x. So here A contains, option A is minus sin x. So the correct answer is A. It is given in blue color and kept in a bracket. So these quiz questions are not only normal questions, these are all standard forms or formulas. So we have to memorize, and better you should write it each formula 10 times, or if you want to write 20 times, no problem, but you must write each one and memorize the formulas. Previous exams questions. So if you observe the questions, how the exams, how they comes in exams, and we can assess and in future exams also, in next exam or in our exams. So that's why it is given here. Find dy by dx of y equal to cos 2x from the first principles. So first principle means here it is a little bit lengthy, because it is asking on basic, that is you have to know first principle, and here y equals to, you have to take f of x equals to cos 2x. And you have to remember and you have to write the first principle and substitute, and according to that you have to find the limit, that is at last you get, that is called dy by dx. So first principle means limit delta x tends to 0, f of x plus delta x minus f of x by delta x. So in the numerator you will get as a cos c minus cos d formula. So you simplify and you use their transformation formulas, that is minus 2 sine c plus d by 2 sine c minus d by 2, and then you have to simplify and you will get the value of the differentiation, that is dy by dx. Second question, differentiate y equals to x cube tan x, that is x cube into tan x. Here he said only differentiate, not from the first principle, so we can use directly by using standard formulas. So it is in the form of uv. So you have to know what is uv derivative. So uv formula is u dv by dx plus v du by dx. Third question, find dy by dx if y equals to under root of 1 plus sine 2x. So here we can first simplify the 1 plus sine 2x as a power, and then square root get cancelled, then we can find the differentiation. So we can write 1 as a sine square x plus cos square x, and sine 2x as a 2 sine x cos x. So then it is in the form of a square plus b square plus 2ab. So we can write a plus b whole square. So then sin x plus cos x whole square, then square root get cancelled, then y equals to, we have sin x plus cos x, then we start differentiation, then we will get easily cos x minus sin x. So this is the process. So by looking root we should not worry, we have to think, is there any chance to remove the root? So that is here we have to think. So assignment, up to now you learned the formulas and you know the applications of formulas, and you know how to simplify, though it is from first principle or direct formula or standard forms. So you try, for you these assignments, this assignment is given, find the derivatives of the following with respect to x. Number 1, x into tan x. So that means you can apply here uv formula. So dy by dx of uv equals to u dv by dx plus v du by dx. Second one, x square into sec x. Same here also, we have to follow the UV formula. So write UV formula and substitute in that formula. U as a x square, V as a sec x. So UV formula is U dV by dx plus V du by dx. Third one, 1 plus tan x by 1 minus tan x. That is U by V formula. So U by V means V into du by dx minus U into dV by dx whole divided by V square. V du by dx minus U dV by dx by V square. Number 4, A minus B cos x by A plus B cos x. This is as like third question, that is U by V. So U is A minus B cos x and V is A plus B cos x. So U by V formula is d by dx of U by V equals to V into du by dx minus U into dV by dx whole divided by V square. By using this, you can find the fourth answer. So in our exercise in the math textbook, so many problems are given. So before going to do that exercise problems, first you understand example problems and then start exercise problems. And if you have any doubts, you can call me or ask me. You can ask me on WhatsApp also or message me. I will clarify your doubt.